Sound. Production of sound. Sound is produced due to the vibration of objects. Vibration is the rapid to and fro movement of an object. Examples: human voice, vibration of vocal cords, stretched rubber band, vibration to produce sound. When we hit the drum, membrane of the drum vibrates, producing sound. When we play a guitar, the string on it makes to and fro motion and produces sound. Sound produced by vibrating prong of tuning fork. Propagation of sound. Sound travels in a medium in the form of longitudinal wave. A wave is a disturbance which moves through a medium by the vibration of the particles of the medium. Since sound waves are produced due to vibration of particles of medium, sound waves are called mechanical waves. The sound produced by a vibrating object travels through a medium to a listener. When an object vibrates, the particles around the medium vibrate. The particle in contact with the vibrating object is first displaced from its equilibrium position. It then exerts a force on the adjacent particle, and the adjacent particle is displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process repeats in the medium till the sound reaches the ear. Sound needs a medium to travel. Sound is a mechanical wave and needs a medium for propagation. Sound travels through solids, liquids, and gases. Sound does not travel in vacuum. Characteristics of a sound wave: compressions and rarefactions, crests and troughs. The distance between two consecutive compressions, crests, or two consecutive troughs is called wavelength. It is represented by the symbol lambda. Its SI unit is meter. Frequency of sound wave. The number of oscillations per unit time is called the frequency of sound wave. It is represented by symbol F, nu, or V. Its SI unit is hertz. Time period of sound wave. The time taken for a particle of the medium to complete one full oscillation when a sound wave passes across it is called the time period of the sound wave. It is represented by letter T. The SI unit is seconds. Frequency and time periods are reciprocal for each other. Amplitude of sound wave. The maximum displacement of the particle of the medium on either side of its mean position is called the amplitude of the wave. The amplitude of sound is the height of crest and trough. It is represented by letter A. Pitch and loudness of sound. The pitch of sound, shrillness or flatness depends on the frequency of vibration. If the frequency is high, the sound has high pitch, and if the frequency is low, the sound has low pitch. Speed of sound. The speed of sound is different in different media. The speed of sound is more in solids, less in liquid, and least in gases. The speed of sound also depends on the temperature of the medium. If the temperature of the medium is more, the speed of the sound is more. Here are some examples of speed of sound in different media at 25 degrees Celsius. Reflection of sound waves. The return of a sound wave on striking a surface such as wall, metal sheet, plywood, etc. back in the same medium is called the reflection of sound wave. The requirement for the reflection of sound wave is that the size of the reflecting surface must be bigger than the wavelength of the sound wave. The phenomenon of reflection of sound wave is utilized in making a megaphone, soundboard, and ear trumpet. Echo. The sound heard after reflection from a distant obstacle such as cliff, a hillside, wall of a building, edge of a forest, etc. after the original sound has ceased is called an echo. Conditions for hearing an echo. The minimum distance between the source of sound or observer and the reflector in the air must be 17 meters. The size of the reflector must be large enough as compared to the wavelength of the sound wave. The intensity of sound should be such that the reflected sound reaching the ear is sufficiently loud to be audible. Reverberation. Echoes may be heard more than once due to repeated or multiple reflections of sound from several reflecting surfaces. This causes persistence of sound called reverberation. In big halls or auditoriums, to reduce reverberation, the roofs and walls are covered by sound absorbing materials like compressed fiber boards, rough plasters, or draperies. Use of multiple reflection of sound. Megaphones, horns, musical instruments like trumpets, sehnais, doctor's stethoscope. Sometimes a curved soundboard is placed behind the stage so that the sound after multiple reflections spreads evenly across the hall. Uses of echoes. Bats make use of ultrasonic sound waves to detect prey. By hearing the echo, bats come to know, even in the dark, the location of the obstacle, so they turn away from their path and fly safely without colliding with it. This process of detecting an obstacle is called sound ranging. Dolphins detect their enemy, an obstacle, by emitting ultrasonic waves and hearing their echo. They are ultrasonic waves for hunting their prey. A trowel man and a fisherman sends an ultrasonic pulse from a source, a very high frequency vibrator, into the sea and receive the pulse reflected from the shoal of a fish in a detector. Natural, damped, and forced vibrations, resonance. Natural vibration. The periodic vibration of a body in the absence of any external force on it are called natural or free vibration. Example, when a tuning fork is struck against a hard rubber pad, it vibrates with its natural frequency. The vibration form longitudinal waves in air, which when reach our ears, sound is heard. This sound is of a single frequency, that is, it is a pure note. Damped vibration. The periodic vibration of a body of decreasing amplitude in presence of a resistive force are called damped vibration. Example, a simple pendulum oscillating in air or any other medium executes damped vibration. Forced vibration. The vibrations of a body which takes place under the influence of an external periodic force acting on it are called forced vibrations. Example, in a guitar, when an artist plays on the string by his fingers, the vibrations in them cause forced vibration in the air, enclosed in its hollow box. Resonance. Resonance is a special case of forced vibrations. When the frequency of externally applied periodic force on a body is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. This phenomenon is known as resonance. Condition for resonance. Resonance occurs only when the applied force caused forced vibration in the body and the frequency of the applied force is exactly equal to the natural frequency of the vibrating body. Demonstration of resonance. Experiment 1. Resonance with tuning forks. The vibrating tuning fork A produces forced vibration in the air column of its sound box. These vibrations are of larger amplitude because of large surface area of air in the sound box. They are communicated to the sound box of the fork B. The air column of B starts vibrating with the frequency of fork A. Since the frequency of these vibrations is the same as the natural frequency of fork B, the fork B picks up these vibrations and starts vibrating under resonance. Thus, the two sound boxes help in communicating the vibrations and in increasing the amplitude of vibrations. Experiment 2. Forced and resonant vibrations of pendulums. Pendulum A is set into vibration by displacing its bob to one side. Pendulum B also starts vibrating initially with a small amplitude and ultimately it acquires the same amplitude as pendulum A initially had. When the amplitude of pendulum B becomes maximum, the amplitude of pendulum A becomes minimum because of sharing of energy by them. Therefore, the amplitude of pendulum B decreases and that of A increases. This process continues. The vibration of pendulum B are in phase with those of A, that is, they reach their extreme positions on either side simultaneously. The pendulum C and D also vibrates, but each of them vibrate with a small amplitude. Some examples of resonance: resonant vibrations of pendulum, resonance in machine parts, resonance in air column and tuning fork, resonance in a stretched string and a sound box of musical instruments and sonometer, resonance in a bridge, resonance in radio and TV receivers. Question: a vibrating tuning fork is placed over the mouth of a burette filled with water. The tap is opened and the water level gradually falls. Question A: what do you observe? Name the phenomenon. When does it happen? Question B: if the water level in the burette falls further, will you notice the same observation again as in part A? Solution: observation: as the water level is allowed to fall gradually at a particular level of water, that is, for a certain length of air column, the loud sound is heard. Name of the phenomenon is resonance. It happens when the natural frequency of the air column, which depends on its length, becomes exactly equal to the frequency of the vibrating tuning fork. The air in the column now vibrates with large amplitude and conveys more energy to the ears, so a loud sound is heard. B. Yes. If the water level in burette falls further, a loud sound will again be heard when the length of the air column becomes 3 times. At this stage, again the natural frequency of air column will be equal to the frequency of the vibrating tuning fork and resonance will occur. Characteristic of sound: loudness and intensity. Loudness. Loudness is the characteristic by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and quality. Loudness of sound depends on the amplitude of wave. The unit of loudness is phone. Factors affecting the loudness of sound. Loudness is proportional to the square of amplitude. When a body vibrates with greater amplitude, louder sound is heard. Loudness varies inversely as the square of distance from the source. The closer the source, louder is the sound. Loudness depends on the surface area of the vibrating body. Larger the surface area of the vibrating body, louder is the sound heard. Loudness depends on the density of medium. More the density of the medium, more is the loudness. Loudness depends on the presence of resonant bodies. The presence of resonant bodies near the vibrating bodies increases the loudness of sound. Pitch or shrillness and frequency. Pitch is that characteristic of sound by which an acute or shrill note can be distinguished from a grave or flat note of the same loudness. Pitch of a note depends on its frequency. Two notes sounded on the same instrument with same amplitude will differ in pitch when their vibrations are of different frequencies. Example of change in pitch. In case of flute, a lower note is obtained by closing some more holes so that the length of vibrating air columns increases. As the water level in a pitcher kept under a water tap rises, the length of air column decreases, so the frequency of sound produced increases. That is, the sound becomes shriller and shriller. Thus, by hearing the sound from a distance, one can get the idea of water level in the pitcher. Quality or timbre and waveform. Quality of sound is that characteristic which distinguishes the sound of the same loudness and same pitch but emitted by two different instruments because of change in their waveforms. The quality of a musical sound depends on the waveform. Comparison between music and noise. Music: it is regular, smooth and pleasant to ears. Noise: it is harsh, discordant and unpleasant to hear. Music: it is produced by vibrations which are periodic. Noise: it is produced by an irregular succession of disturbances. Music: the sound level is low, between 10 decibel to 30 decibel. Noise: the sound level is high, between or above 120 decibels. Music: the waveform is regular. Noise: the waveform is irregular.